back to the mean value theorem speeding question. So the way it's laid out in the book, and this is confusing both me and JM, is it they give you the speeds, forget the speeds. Okay, because it's kind of irrelevant for what we're doing here. You got to think of it as this. The mile marker on a highway is at 20, and that's when the police first spot you, and they click their timer. That's 0 minutes. T1 is 0 minutes. At mile marker 25, they stop this timer, and that's 4 minutes. Okay? Just to keep this in hours, 4 divided by 60 is 1/15 of an hour. Okay? So on a graph, this is when the police start the timer, all right, at 10 o'clock, T0, and they give you the speed, but you don't actually need to know those because I think it's a red herring in this question. And then at 10:04, they stop the timer. This is a position graph. You are at the 20-mile marker, then you've gone to the 25. So if we do rise over run, y2 minus y1, x2 over x1, you're going to get 25 miles minus 20 miles divided by, well, it's going to be 4 minutes. 4 minutes minus 0 minutes. So I end up with 5. No, why did I do minutes? It should be hours. That's okay. 5 miles divided by 4 minutes. Up here, we converted the minutes to 1/15 of an hour. So this is like 5 miles divided by 1/15 of an hour. So you flip the bottom fraction, and you get 5 miles times 15 over 1 hours, which is 75 miles per hour. Okay, so what that means is, assuming, and this is the key part, assuming there are no gaps, jumps, PODs, points of discontinuity. In other words, the graph is continuous and differentiable. Then at some point you were traveling at 75 miles per hour. Okay? Because to go from A to B in that amount of time, you had to be going at least 75 miles per hour for a certain amount of time. That is what the mean value theorem says. Okay? That the average velocity, if the average velocity is over the speed limit, then at some point you exceeded the speed limit of 55. I hope that makes sense. Good night.